S union 1. So it is 0 and 1. Then what does follow? Follow of S is, what is follow of S? It is first of 1. First of a terminal is always a terminal. So 1 and dollar. And follow of S dash is follow of S, because follow of S dash is nothing. So follow of head of the terminal will be there. So follow of S. So it is 1 comma dollar. Now you consider the first set for S 0. So you have only one production from S. So I will be writing S producing 0 S dash. The first set of S dash is 0 and 1. So which one you will use to go to 0? Which of the production you have to apply if you want to have leftmost symbol as 0?
S dash derives S1.
Correct. So S dash derives S1. So for 1 it is straightforward. S dash derives 1. Now what is the confusion? Manjunath, what is the confusion? You got it wrong, the table? This is N A comma A, and this is input symbols. So you take input, stack, matched, and action. So in the input, the string which is given is 0000111. So 0000111 dollar. Top of the stack, we have to start with the starting symbol. So I have pushed S on top of the stack. Then matched is nothing, action is nothing. From S on 0. S on 0, I have only one production to use. That is S producing 0 S dash. So 0000111 dollar. All of you come and do it. 0 S dash. I have replaced S with 0 S dash because of this production and a dollar. The action which I have taken is S giving 0 S dash. Okay, so input pointer and the top of the stack is same. So I have to pop out and put it onto the matched and move my pointer. Input pointer 00111 dollar S dash dollar. So you have 0 matched. Matched 0 is the action. Now input pointer is 0 and top of the stack is S dash. So refer the table for 0 on S dash is S dash on 0. I have to use S dash producing S1. So 00111 dollar. So S1, I'm replacing S dash with S1 and a dollar. Matched is 0 and I have used S dash giving S1. Now top of the stack is 0 and top of the stack is S. Input pointer is pointing to 0. S on 0, it is 0 S dash. So 00111 dollar 0 S dash. S is replaced with 0 S dash, 1 as it is and a dollar. So 0. What did we do? S is replaced with 0 S dash. So top of the stack and the input pointer is matching. What do? You move the pointer to the next character in the input and pop out from the stack. So you remain with S dash, 1 and dollar. You get 2 zeros here. So you have matched a 0. So from S dash on 0, what do? S dash on 0, it is S1. So 011 0, sorry. On 0 it is S1. So S1, S dash is replaced with S1 and the 1 as it is. So what do? You have replaced S dash with S1. Now 0111 dollar. S on 0. S on 0, I have only one production. So 0 S dash 11 dollar. You have 2 zeros. You have used S giving 0 S dash. Now top of the stack and the input pointer are same. So I move my pointer. So it is 111. Pop the 0 on top of the stack. You remain with S dash 11 dollar 000. So you have matched a 0. Okay. Now I'm just removing some lines above so that it's easy. Okay. Now top of the stack is S dash and input pointer is pointing to 1. So S dash on 1, it is S dash producing 1, right? So dollar, and S dash is replaced at 1, the remaining 2 ones, then 3 zeros in the matched. So what did I do? I replaced S dash with 1. So now top of the stack and the input pointer are matching. I move my pointer, pop it out, remain with 2 ones, 0, 0, 0, 1. You have matched a 1. So top of the stack and the input pointer are same. You remain with 1, 1 on both stack and the input pointer. So you get 0, 0, 1, 1. So you have matched a 1. And again you get a match. You remain with dollar, dollar, get 0, 1, 1, 1. You have a match. So both on the stack and the input pointer I got a dollar. That's why I have completely passed this string, so it stops here. Any doubts? Where did you go wrong, Manjunath?
Table only on that. I didn't consider that transition properly.
Okay. Maybe you got confused for 0 and 1 which one to use.
Yes, ma'am. I had written that in the opposite way.
Okay.
The S dash 1 I wrote first because I didn't know where it is.
Okay. So always you have to see from S dash at the leftmost side because we are doing LMD, right? So how do I get 0 on the left side? So if you apply first on S1, then you should be able to get 0 on the leftmost side. That production you have to choose to write it under the input symbols. Okay. Now,
Ma'am, first we see whether the grammar is like we change the grammar also, right?
yes. So the original grammar was 0S1 or 01. So first step, you have to see whether it is left recursive or in short, if I have to say, make it LL1 if it is not LL1. Okay. So left recursive or left factoring you have to remove. Okay. You follow this step as a general rule. Then if it is failing, even if you remove the left recursion, okay, fine. First you remove it, then you calculate the first and the follow sets. Okay, then the third one is parsing table. So how do you construct the parsing table? Using the first set, using the sets in the 2. Step number 2, whatever you have generated, that's step number 2. You have to consider those first set. If you get epsilon, then you have to use the follow set. Then fourth one is the parser table. This is the parser table. Construct the parser table. Okay, these are the general steps. So first thing is the given grammar. Once you remove left recursion or left factoring, it is also possible that once you have to remove both you have to check. Okay, left recursive or left factoring. Sometimes once you remove left recursion, you get left factoring, that we have discussed, right? So you have to make it LL1. Even after you remove left factoring or left recursion, while constructing the parsing table, you may get double entries. Okay, in that case, you can straight away say that it's an ambiguous grammar. So further parsing cannot be done. Okay, with stating that why it is ambiguous. So we have seen. Did I give you that example wherein you get multiple entries in the table? The if else one?
No, ma'am.
No. Okay. So if what?
Ma'am, but like last class you said we should not do left factoring or left recursion.
Where?
In
No.
LL1.
If the question is check whether the given grammar is LL1 or not, then you shouldn't do it. But if the question is for the given grammar for the given string, show the parser table. In that case, what you have to do? What are the what are the steps you have to follow? Is this: you have to make it LL1 because the parser does it. Right, the predictive parser does it. It has the algorithm for removing left recursion, left factoring, and then calculation of first set, follow set, parsing table, everything we have seen, right? So if the question is to parse a given string, then you have to see how to make it LL1. Even after you make it LL1, in the parsing table, if you get double entries, then you can say that it's an ambiguous grammar and cannot be continued. For example, if you remember this if else statement, which we had discussed, S ES or ETS or A and E producing B. This was the original grammar. Now this we have, according to the step 1, what we should do, what it has?
Left recursion.
A.
Left
No,
factoring.
left factoring, ma'am.
Left factoring. So this is if expression then statement, else statement, if expression then statement. It's like one is if else, one is a simple if condition, or a, which is referred by a statement. A statement can be replaced with a, or expression is b, any logical expression. Okay, so there is a left factoring because both the productions are starting with iets as a common string, right? So in the effort of making this as ll1, so what it does according to step 1, we remove left factoring, right? So the grammar is converted like this. Sorry. S dash a as it is, S dash is producing the remaining ones es or epsilon, and you get e b. Quickly draw the passing table for this grammar. So now, if according to LL1, so okay, let us. According to LL1, the first rule says the same string, it shouldn't start with the same terminals, two productions from the same non-terminal, right? The rule 1 is satisfied. Now we have to see the first set and the follow set, right? For the other two. And second rule is one of the production can derive epsilon. That is also true, right? Now calculate the first set. So what is first of S? It is what it is?
I and A.
I and A. I and A. First of S dash is E and epsilon, and first of E is B. Yeah, what is follow of S? S.
Ma'am, what are the terminals and non-terminals in this? Small I is a terminal.
Yeah. Smalls are terminals. I, T, A, E are B are terminals, and the others are non-terminals.
T and E follow set of S.
Follow set of S. So follow set of S is first of S dash, right? So what is first of S dash? It is E. Epsilon I cannot include, so it won't be there. And also the dollar will be there since it is a starting symbol, right? Then
Ma'am, follow set of S will be follow set of S dash, right?
here, yeah. Union.
Ma'am, you said first set.
No, here. There are two places where you have S.
Okay, ma'am. Yes.
Okay. So a follow set of S is first of S dash with respect to this production, and follow set of S is follow of S dash with respect to this production. So follow set of S dash. This is not yet completed. So what is follow set of S dash? It is follow of S. So it is recursive. Right? Now, so we get only E and dollar in both the places. What is follow of E? Follow of E is? Follow of E is?
T, ma'am.
T. Yes. Okay. Now, when you draw the passing table, you have.
Ma'am, how did you eliminate that recursion that follow set of S dash and then follow set of S?
No, you can't.
So
If you get a few more terminals, then you can add all of them. So you cannot do it. So that's why it is only E and dollar. That's all.
okay, so we just ignore the recursive.
Yes. So you have I, T, E, A, B, and a dollar. So you have here S, S dash, and E. Okay. Now consider the first set from S, I, and A. Right? So how do you derive I from S? Yes. So it is S derives I, E, T, S, S dash. And for A, it is S derives. My table has become very tiny. So S derives A. Okay, if you consider S dash, now there is a problem. Since I have a E in the first set, also I have E in the follow set, right? So S dash on E. Which one I have to use? S dash producing ES, right? Since I have an epsilon, what does the rule say? I have to use the follow set of S dash. Whenever I have an epsilon in the first set, I have to use follow set for the same non-terminal. So I have E and dollar. So I get S dash giving epsilon on E and S dash giving epsilon on dollar, both. And E, of course, I don't have any problem on B, E giving B. Okay, so I have 2 entries in the parsing table, even though it is passing the rules for LL1. That's why, see, you can say that if you get in the third step similar to this parsing table, wherein you get double entries, if you calculate the first set and the follow set properly, okay, all grammars won't be like this. Only few grammars will be like this, because every grammar is not, LL1, right? That's why we go for bottom up parsing, so that it can cover more, this kind of grammars. Okay, so LR type of grammar.
Ma'am, could you explain this part again? Like, since S dash has E in follow set as well as first set, so we did this. Like, why did we do it?
Yes, Furkan?
Ma'am, could you explain this part again? Like that S dash derives ES and S dash derives epsilon.
You didn't get how these two came into one cell?
Yes, ma'am.
So the follow set, when you're constructing the passing table, you just check the rules. Have you written those rules on your notebook? So whenever you get an epsilon in the first set, what should you do? Passing table construction, we use first sets, right? For each of the in the follow set. Did I lose connection? This, how to write the passing table. So now, whenever you get that, here if you see, it's as an input symbol follow set. Now what, whenever you consider the passing table, it is always, I have to write that non-terminal giving epsilon under all the terminals which are there in the follow set. So I have to write under E, S dash producing epsilon, and under dollar S dash producing epsilon. But according to first set also, I have one production here. So there is a confusion.
Ma'am, your voice is breaking, ma'am.
It's not audible.
Like
Now it's audible?
And now it's fine. Now. But like the explanation part we lost.
Okay. Let's just remove this. Furkan, now you tell me, how do you write the passing table entries? How do you mark the terminals for S dash? Furkan? Now I'm audible or not?
Yeah, you're audible, ma'am.
Okay. So when you consider the first set for S dash, you have E and epsilon. So the passing table construction algorithm says whenever you get epsilon in the first set, you have to consider the follow set for that non-terminal as well, right? So, and write that non-terminal giving epsilon under all the terminals which you find it in the follow set, right? So according to that, if I have epsilon in S dash first set, so for E I will write a straight away? ES, because first of ES will get E at the leftmost side. So on E, S dash is giving ES straight away, but epsilon is there. So according to the algorithm, I have to consider the follow set for S dash. So you have E and dollar. What do you write under E and dollar? It is S dash giving epsilon. So I have multiple entries. Entry, there is a double entry. Okay, let me change my.
Ma'am?
Yeah.
Ma'am, you had given 3 rules for deciding whether the given grammar is LL1 or not. So, like, does this grammar which you just gave, does that violate any of those rules?
No, you just check after left factoring. The first rule we satisfied, right? What are the rules for LL1?
Yeah, so the first 2 are satisfied. I was a bit confused about the third one, that if beta gives epsilon in 0 or more steps, then alpha does not derive any string beginning with a terminal and follow away. So
Alpha does not derive any string beginning with a terminal in follow of A.
So follow of S dash here because the epsilon is there.
Follow of S dash. No. If this is deriving epsilon, then any string with the terminal which is there in follow of A.
So
The third
if
rule.
E is there in follow of S dash, the small e.
Small e is there. Yes. So even after you remove left recursion and left factoring, because the algorithm just says that you have to remove left recursion and left factoring. Okay, your non-recursive predictive parsing. It doesn't check for the third rule. So it just checks for left recursiveness and left factoring to be able to convert this given grammar to LL1 if it is not there. The third rule, it cannot, it cannot be coded. So that is found out in your parsing table construction only. Okay, according to it, after satisfying the first one, it should be LL1. Okay, but the third rule, how do you verify? The third rule is verified only when you construct this parsing table. Only then it is verified.
So this grammar is not LL1, right?
It is not LL1 grammar, even if you remove left recursion or left factoring. Okay. Or you can always state, you can derive that third rule and say that it is not LL1, or you can construct the parsing table and say that it is not an LL1 grammar. Based on the marks on the question, you do it. Okay, if it is 5 or 6 marks, then the parsing table is expected. Okay, if it is for 2 or 3 marks, then you can using those rules, 1, 2, 3 rules, you can just say that this is not satisfying one of the rules, and you can say that it's not LL1. Okay.
Yes.
Now the next thing is, you see there are a lot of empty spaces. Now this is reached when top of the stack is S and the input pointer is pointing to 1. Then it's a error, because from S I cannot derive N. 1. I have to go to S dash from S, and then only I can see 1. So that is an erroneous condition. Then one more condition is on dollar. When you have dollar and there are some input symbols which are still remaining, top of the stack is S. Still you have S on top of the stack and you don't have anything in the input buffer, then it leads to this one. Okay, then S dash also, top of the stack is S dash and input is already passed, already been done. You don't have anything in the input buffer, but still the stack has some non-terminals on top of the stack. That time you will be led to this condition. Now these are the conditions wherein the parser can be halted. So what do you do to overcome this error? We have discussed few error recovery strategies in the beginning which are handled in syntax analyzer, right? So can you name them? Do you remember?